design is never finished. That's one thing that's really important. If it were, we wouldn't have careers here. Prototypes, they are an absolutely unbelievable ambassador for your design. Once again, a model is worth 1,000 pictures.
Solutionology is about being unyielding with perseverance to get to the solution. We've got a dear friend as our guest, an inspiring designer and Renaissance man of sorts. That's how I think about Mike Van Staagen. It's someone who is I look up to from design and creativity, and just a great perspective of life and how to maximize it. Mike is currently the Vice President of Advanced Development for Cirrus Aircraft. Mike's got a storied career with Cirrus, an extraordinary career in the aerospace and aviation industry, as well as industries that are complementary to that from an advanced development standpoint. So, Mike, today you're with Cirrus. You're VP of Advanced Development. But, your career is absolutely fascinating, and it'd be great if you could share with the audience, your career and some of the highlights, some of your most enjoyable highlights.
As I get older, you start to feel like teaching people. It's just a natural evolution, I think, of humankind to share our learned experiences. And so this is a great opportunity for me to have an outlet to try to share the things that I've learned. I'd say my career started when I was 5 years old. My mom and dad flipped houses when we were kids, and I grew up among sawdust and plastered walls without paint, half-finished basements, and so on and so forth. But my dad had a big fat book on his desk that said architecture across the top. And I would flip through that picture book and was enamored with the pictures of walls and cross sections and floor plans and the systems that go inside of a house. And he was also an avid model airplane enthusiast. And the dining room table was usually full of ribs and spars and wheels and engines. And it was funny because architecture and aviation were the two sort of hallmarks of what I thought I was going to be, not an astronaut or a policeman, but definitely I was thinking architecture. And airplanes to me at the time wasn't a career path. I didn't really understand what it would be like to be an aviation designer. And so all through grade school and high school, I flew model airplanes myself, built some scratch ones, designing them, drawing them on paper and trying to make them. Fast forward to 10th grade in high school, took an aerospace class and a drafting class, and really fell in love with aviation at another level. So model airplanes is one level. And then when you start to take a 101 class in aerospace, you start to recognize that an airplane is just like a building. It's it's got a structure. It has doors that you go in and out, windows you look out of. It has systems in it, and it's really a very parallel idea to architecture. And of course, I loved model airplanes. I loved designing them. And and a funny aspect about that is, as a model airplane enthusiast, you are on the outside of the vehicle. So you sort of fall in love with what the plane is from an exterior perspective. And this is an interesting angle that has served me really well throughout my career. And it was certainly something I fell backwards into. I gravitated towards the concept of, I'll have architecture as a profession, airplanes as a hobby. And so I went and enrolled at NC State University in their School of Design. But the NC State's approach to architecture design was really not about buildings, which was strange to me. But looking back on it, it was the perfect education, because what NC State was doing for me was helping me learn how to think. And that is the basis for pretty much everything in my career, was how to think. Another aspect about the architecture profession is that this is typically a profession where the architect is a service-oriented business. So the architect needs to listen to their customers. The customers usually don't know exactly what it is they want. And so you have to be some private investigator and someone who can envision things, and more importantly, communicate ideas once you start going, to be able to try to connect with these customers. And learning how to listen and interpret all kinds of different ways of communication, whether it's pictures that are cut out of a magazine, hey, here's a fireplace detail or a deck detail that I like. to words from different people. Often the architect interviews lots and lots of different people, so it's a collaborative effort, and the architect gets to sort of pull them all together. And I would say the most attractive part of architecture is that you get to try to bring the art form or the conclusion that satisfies everybody, but you get to twist it. You get to make it look a certain way. The effort to communicate your ideas was typically making drawings, sketches at first, and then more formal line drawings with pens and paper and mylar, if you will, and straight edges and things like that. And the second piece of that was creating models. So we make foam core models. Obviously start out, and like I said, when we were doing the few architecture projects we would do, we'd literally build little models of our designs. But our sculptures and our paintings, of course, were made out of different medium. Was really learning how influential models, the physical 3D version of your designs, how powerful those were in communicating an idea. And this was complementary to my model building skills that I developed as a kid building model airplanes. So it really started to come into clarity that a funny saying that I'm not sure who authored it, but it's one of my favorite ones, is if a picture is worth 1,000 words, then a model is worth 1,000 pictures. And I love that. And I think that is one of my favorite takeaways from my experiences. That, and if you believe in that, you would want to invest in making models as opposed to drawings. So to pick up from there, I got my undergraduate degree in architecture and was aware of, just by a little bit, of an industry called the kit plane industry. And it's just as it sounds. It was an industry of people that were building airplanes, literally airplanes that they would build in their garage, whether it came from plans or a partially created kit from a manufacturer. People would build airplanes, assemble them in their garage, make them airworthy, and then go fly them. And this was a really interesting idea to me. One of the most influential moments was I went to an annual pilgrimage to Oshkosh, Wisconsin, called AirVenture. This is the world's largest gathering of airspace aviation enthusiasts, with some 14, 15, 16,000 airplanes flying in for the event, week-long event. I went there in 1991 and was absolutely blown away by one of these cool airplanes, these kit planes, that was flying down the runway at 250 miles an hour. And it looked absolutely different, but it was gorgeous. It was flowing. It was beautiful in every way. And not only that, it was one of the highest performing airplanes that had been created in that power class. And it was done by a product designer, an industrial designer, product designer. And that was sort of when the switch turned on that said, why are you being an architect? and shouldn't you be an airplane designer? And of course, you walk around Oshkosh and there's airplanes that were scratch built that you looked very scary, to very professional airplanes like I'm referring to. And one of those companies happened to be Cirrus Design at the time was the name. It's now Cirrus Aircraft, but Cirrus Design. And they had a very fancy, beautiful, slick aircraft called the VK30. And what was really interesting about this is that the airplane had just really unique lines. It had a propeller in the back instead of the front, and it was long, skinny wings. And anyway, all I can tell you is once I was at Oshkosh and saw these airplanes, I was hooked. And I wanted to try to figure out how to move my career from architecture to aerospace design. And that's exactly what I did. I went to grad school to finish my architecture degree because I could never become a licensed architect without a master's degree. So I went and did that. But between my fifth and sixth year, I reached out to Cirrus and to see if they would do summer internships. And lo and behold, they did. So I spent my summer in a little town called Baraboo, Wisconsin, working in what I would call a glorified garage business. I think they had about 50 employees at the time, and they were building these little VK30 kits. During that time, they were working on a new design under contract, and I can tell you that it didn't jive with me. I didn't like it that much. Everyone seemed to like it, and the customer that was hiring Cirrus to build it liked it. But I really didn't. There was things that I wanted to tweak. I wanted to go in there and massage and make it a little bit more racy and sweep it back and add some more aesthetic appeal to it. And when I left the internship, I wrote them a letter that basically said, hey, I think you ought to add somebody that comes from the product design perspective to your engineering staff, and maybe that blend would be perfect. The two owners received that message loud and clear. And after I graduated, I literally after I finished my last exam, I jumped in my U-Haul and drove from Texas A&M University up to a new home that they had created in Duluth, Minnesota, which is where I live and work today. So what a cool way to end up in an aviation company, and I have really never looked back. This is absolutely the best possible way, best possible career. And what was really interesting, guys, was that there was no possible way I would have figured out what the proper education would have been for a designer in an airplane, a small little airplane company like Cirrus. But going to NC State, doing sculptures and paintings and marble mechanisms was a great education to set me up for being successful at Cirrus.
What a bold move as an exiting intern to draft such a letter and send it along. I absolutely love that.
Yeah, it's a recurring theme. I'll tell you that. With bold moves comes sometimes really bold results. And that's true. The most flexible part of an aircraft's design is the interior. Wings have to be wings, tails have to be tails, and so on. But the interior is really where you could unleash personality. I'm not an industrial interior designer. That is a skill set that is also really hard to achieve. But I'm very conceptual, and I can get the concept. I had some really strong ideas for the concept, and which were boiled down from looking at all of the different cars that were being made at the time. And we boiled down some interesting iconic elements. First, most airplanes are symmetrical in that the left side and the right side front seats are the same. They're usually set up that way because you're going to train in an airplane. So there's controls on the right, there's controls on the left. There's so many instruments that go on the instrument panel that the panel would largely go across the whole front of the airplane. And I didn't like that. And cars were asymmetrical. They're driver-centric, they're driver-oriented, and typically for American cars on the left side. And the right front seat in a car is for a passenger. And literally all that you have typically on the side is the glove box and some heat controls and vent controls. So wanted to bring that over. There was a center console in an automobile. And with composite construction, we were able to actually make the airplane wider without causing more drag. And so we could retain the performance of the airplane, but we could then separate the two people, which usually rubbed shoulders in small airplanes. I could separate them by about 4 inches and slide a center console, a lot like your radios, down in every car that you've ever been in. We wanted to put that in there. And then the third one was extremely good visibility. So it was bringing the glare shield that keeps glare off of the instrument so you can see them in all lighting conditions. Wanted to bring that down so you could have good visibility out the front. So as I was watching this design contractor and one of the owners work on the inside of our aircraft, we were making a mock-up to take to Oshkosh. I noticed what they were creating was just horrible. And it was okay. Let's say it's okay from one perspective. It was horrible from my perspective. And so I had a little box of Sculpey clay that I had brought in, which was left over from my college days. And I hadn't even drawn an idea yet, but I knew about those three elements, the asymmetry and the center console things. So I very quickly made a small, and I'm holding up my hands here, about 5 or 6 inch clay model of what I thought the instrument panel would look like as fast as I could, and brought that down. And one of the tricks that I had learned in architecture school was that if you take a small model and you hold it very close to your eye, you can sort of see it in scale, at full scale. So I walked up to the airplane. They were both sitting inside of it, and I had my little clay model. And I tried to explain to them the concept that I wanted to do. I looked over at the designer who I was stepping on his toes, and he was not happy. He was shooting daggers at me with his eyes. The owner of the company was looking at it, and I was trying to explain my idea, and I showed him the model, and he was looking at the model, and I said, look, bring the model up to your eyes and sort of put it in the airplane where you think it would be, and tell me what you think. And he looked at it, and it was like the light switch went on. And I could see it. It was working. And he literally handed it over to the contractor who did the same thing. And he handed it back. And he kind of gave that kind of a whatever. I don't see where this is going. And Dale Klettmeyer, the owner, looked at it again, handed me the model, and he just literally ripped everything out that they had been painstakingly putting in there with cardboard and trying to mock it up. Just ripped it out. And he turned to me and said, "You're in charge of the interior from now on." So that was one of those bold moves, just like writing that letter, that happened that really changed the trajectory of the Cirrus product line. It was just a move like that. Once again, a model is worth 1,000 pictures. And so it really proved to me, beyond a shadow of a doubt, that this is a skill, this is a technique that I can leverage to get the results. And it wasn't just for me, it was really for the company. And interestingly enough, that exact design, which was improved by an extra company that came in that had the industrial design abilities that I did not have, but the concepts are still very much in the picture that's behind me. And that is the design that I showed them back in 1994. And we still sell that today. So it just goes to show how important getting these things right are, and if they're really well done, they last a long time, especially in aviation. Those were some of the stories and some of the things that helped sculpt my belief in prototyping and visualization in 3D. And of course, the thing that comes all the way to today is how fast can you create those ideas, and how fast can you get those ideas in front of somebody? Because everything is so fast these days, and additive manufacturing is one of those elements that has made making these models a real pleasure to incorporate into our daily work.
Something that I didn't appreciate until I heard your story today. It takes me back to when we came to visit you, and we were in your home office, and that day it was organized, so maybe a little different than it is today, but it was very organized. And we went through the amount of models that you have hanging from the ceiling, and even your model cars and the way that you have things organized. It's like, from a design perspective, you put all of this media around you to have context and inspiration to continue. A lot of it you've built yourself. In some cases, you're looking at others. But it's just inspiring to hear your story and how you've worked with your hands, and you've built all this 3D visualization before we had a rapid process to really go through it, so that you can tell your story. You can translate all of the communication you're hearing and what you're seeing in the world around you. It's really neat.
Yeah, no, I appreciate that. No, I live inside of a model. I mean, it is. I've probably several hundred models that are around me for inspiration, just like you said, Brian, and also to remember, a design is never finished. That's one thing that's really important to recall, is that if it were, we wouldn't have careers here. But design is never finished. It's amazing how you can go back and look at something and see opportunities that you missed. It's relentless. You have to accept that.
And that's charging a lot of fun. That's resulting, I'm sure you're having a lot of fun, and those around you that get to work with you are also having a lot of fun, breaking those molds and challenging the areas around you.
Yeah, and the I would say the biggest chore that I have here at Cirrus, if it's a chore, is I don't believe the engineering education system cherishes the mock-up and prototype portion of design as much as the more art side of design, like architecture does, and industrial design. You constantly see industrial design, like car companies showing, people pulling clay still. They're still doing clay models because there's a tactileness to it. There's a life that is created when you are creating those shapes in full scale or at a smaller scale, but you're doing it in a human space. The computer, while I work behind one every single day and use software that helps me visualize 3D things in the computer, it's still a 2D image. It's still a picture. And I'll tell you, there is a disconnect between designing in a computer and reality that absolutely is relentless, and it never stops surprising me. When you work in a computer and you don't have a scale reference, you get lost. And if you're lost by 10 or 15%, it makes a difference. And we're always lost by 10 or 15%, or if not more. So I'll get prints from you guys, and I'll be holding them, and I'm like, oh my God, this is half the size I thought it was. And this is me talking, who knows. I think I can connect with the visuals on a computer in reality as good as anybody could possibly do it, and it still surprises me. And so I expect that now, and then I roll that into the design process. And so getting your initial mock-ups or prototypes out quickly so you can get that feedback is important. But the engineering discipline, like I said, doesn't. I'm not sure exactly. I'm not trying to say anything bad about the engineering profession here. It's just that there's just so many amazing benefits from prototyping and modeling things in full scale out of the computer. And I will tell you, there's a couple quotes that I like, and it comes from I believe it comes from the fellow who started a company called IDEO. And this is a very well-known product design house that have a lot of great accomplishments to their name. But I believe in an article I read some time ago, I took two takeaways that I tell everybody I can, and that is prototypes provide an opportunity for accidental discovery. Accidental discovery, I will say, has contributed to 50% of the design output that I've created in my life. People say throw something and see if it sticks on the wall. That's exactly what they mean. They're trying, they don't know, and if it sticks, it might be good. Well, accidental discovery is just that. In a computer or on drawings or whatever, you don't connect as well to it. And once you prototype it, and it can be at subscale, and I want to make sure people recognize you don't have to always build things at full scale, but you see things, your mind picks up things, proportions, relationships that are inexplicable as to how it communicates with your brain, but you see things and opportunities that you didn't notice before. And what's absolutely startling is how often we'll create a design here or in other places that I've worked. And once we think we're done, we build it, we look at it, and we're like, oh my God, if we had just flipped that flange over, we could remove that fastener, taken that clip out, made it simpler to build, yada, yada, yada. It's absolutely crazy how often that happens. It never doesn't happen. And so accidental discovery is like a superpower. And I'll tell you one thing, I don't have a lot of superpowers being offered to me. So I'm going to take the ones that I can get. And this accidental discovery is really cool. Now, what you have to do to leverage this is you have to be willing to accept it. And one of the things that I find about my colleagues and peers is that a lot of people get really stuck on a design or a concept or an idea because it took so long or it was very hard to arrive at that they don't want to allow accidental discovery to be part of it. Well, the best way to make accidental discovery occur is to do it at a time where the stakes are not so high. You don't want to be doing accidental discovery when you're trying to put it into production, as an example. You want to do it early in the design process. And so having mock-ups that are lower cost, that are fast to create, that you expect to not be complete is the time to do it. And that's what I use additive manufacturing for, and my prototype endeavors to do is to try to inspire an opportunity for accidental discovery to occur. You literally can drive accidental discovery higher by trying to get things out quicker so you can see them. So very often I'll get a design just a third of the way done, and I'll just go ahead and start printing them because I want to hold them in my hand and start to fall into this accidental discovery mode. And that's one takeaway from IDEO. Another one, which is extremely important, that prototypes can do, is that they are an absolutely unbelievable ambassador for your design. The prototypes themselves are actually what communicates your design. I think everybody that's going to listen to this podcast can recognize people who talk a little too much and people who say one thing, but what they're describing isn't actually what they're describing. And so there's a disconnect between a person describing something and the actual article that you're working on and designing. And of course, at the end of the day, if you're making a product that you're trying to sell, it's very difficult to get that information across to your consumer. Consumers are going to react really quickly to what they see and what they touch and what they feel. And so the product itself is, of course, is the ambassador. So why not use these prototyping tools, these prototyping methodologies to be an ambassador for your designs? It's neutral territory. And I'll add a third item on there. That's my own observation, is that most designers and engineers like to be heroes. They like to solve complex riddles. They want to do that. Showing something halfway thought through, half done, potentially something wrong, is not the first thought that comes to mind when someone sits down and thinks about how they're going to execute the design. So what I call it is people hide in the computer. They actually hide their designs and don't really want to talk about them until they feel comfortable, because they don't want to be, as the worst case scenario, ridiculed. Like, this is a horrible design. I mean, nobody wants to hear that. And so people want to be heroes. They want to solve problems. So they want to delay the communication until they feel comfortable. Well, that's fine. And that does work. That doesn't mean that's an unsuccessful path. But for me, you've robbed accidental discovery from yourself, but more importantly, you've robbed it from your team and other people who can contribute to your ideas. So when you walk by a screen and look at somebody's work, just you can imagine that in your head. How often do you walk by someone's screen and you see enough detail that makes you stop in your tracks, turn around, and go, "What are you working on? Why did you make it that way?" However, if you put a whole bunch of prototypes on your desk, that's like fruit nectar to a fly. That will attract engineers, designers, executives, people from finance, HR, doesn't matter. Everyone sees these little models and they're very intriguing, and they usually pick them up and start playing with them and like, well, what are we trying to do here? And so they really invite people into your design space. And that's why that's one of the big reasons why I like to do that, is to invite people into my design space. I like to think I'm a good designer, but what makes me, I hate to say it, what makes me a better than good designer is the fact that I get feedback from other people. And usually these ideas are extremely easy to incorporate when you are early in the design process. And why not allow that to be like a second superhuman power, leveraging your peers that are literally walking by, going to get a cup of coffee. How do you get them to be part of your design process and help you get to where you need to go? There's a twofold benefit. The first benefit is that you get to harvest their experience by bringing them into your design space. And I'll tell you that many, many, many important design decisions that we made at Cirrus came out of this method, by incorporating other people's ideas, getting them to interact. And the second idea, you reduce the risk of going forward with your design, because boy, are there lessons learned in everybody's head. They're usually not written down. They're usually hard to comprehend if they are. But if I'm working on something and I can get that information communicated to somebody who I wouldn't expect, perhaps the owner comes by and says, "Oh my God, don't do that. We tried that once before, and let me tell you the story." And so it harvests information on multiple levels that you can really leverage. And so having these mock-ups and prototypes are just, as best I can tell, there's no downside to them.
What a profound message that you just delivered. The accidental discovery, the articulation of the results that you've experienced from those accidental discoveries, and then the courage and humility to embrace the accidental discovery through those experiential experiences with prototypes. It's just there. That you said it better than I've ever heard it said before. Extraordinarily captivating, and it's something, if you don't mind, we might borrow some of which sounds like you borrowed from my DEO, and you've just defined the ideal innovation management, or we call product development funnel, to a T of capturing those, getting the concepts out there, capturing the lessons from those concepts as early as possible, so that you can drive through the rest of the introduction, ultimately the introduction with success. And man, the way that you just shared that is just profound.
I'm glad, and of course, everything I'm telling you today is, I would love to hear it, hear that get legs and be broadcast to more people. I think it's all beneficial to all of us, so why not? You bet.
For sure.
I think something that we take for granted in the digital age of CAD design is the step that you communicated and you learned in school, where you're visualizing this idea, and the only way for you to bring it to life is to make it out of clay. When you make it out of clay, in real time, you're tactilely feeling that product, and you can make adjustments to it on the fly because you've got this physical geometry in front of you that you say, well, that doesn't quite look right. I'm going to pull this a different way. And as we go to this digital age with CAD design, we take that for granted. We go right from a napkin sketch to a digital concept. And you're right, it's so easy to think about all these features that we have to have and what it should look like in the digital space, but what the real ratios are and sizes are, we don't know until it's physically there. And it's scary pulling that part out and sharing with others. I had this idea and this is what came out. Do you have any thoughts about it? So we take the digital age for granted, and we miss that opportunity to be tactile early on and get others to contribute to the design process.
Agreed. Absolutely. Yeah, absolutely.
And in a lot of cases, we're using additive 3D printing as prototyping, in some cases too early in the stage, where we could be starting with clay. And we do that with some of our product designs at DI Labs. We start with clay rather than starting with a digital model, so that we can experience it before we even get it into the computer, so that we know a better idea where we're headed.
Those comments you're making inspire this comment that I'd like to share with you right now, is there are shades of gray inside the digital space. And one of the things that I found very taxing was working on complicated CAD systems. And when I mean complicated, I mean where, let's say if your mind can go at 100 miles an hour and maybe you can sculpt clay at 75 miles an hour, it feels like the more complicated CAD programs, which are incredibly capable, they're like 25 miles an hour. And I would argue that you can't make everything that you think of out of clay. There's obviously lots of shop materials and foam core foams and boards and woods and metals. Obviously, tons of prototyping materials are available, but those aren't very necessarily quick either. If you want to machine a little part as a prototype, that would be very difficult. And not to mention, you have to have the CAD work to drive the numerical control anyhow, right? So what's really neat here is that if you look outside of your space, there is software available, which I have adopted in my workflow, that is a version of CAD, but it's much lighter in weight. It's called a Polygon modeler, and some companies that make this are like Blender is the free one on the internet that's extremely good. That's a Polygon modeler. I use a software called Modo, which I've been using for 15 years, and I love it, and I use it every single day. But this is digital clay, and what's interesting is in a CAD system, you can choose 5-10 decimal points when you're trying to figure out how long you want something, and in Modo, the only thing it really has is a horrible digital tape measure that you can kind of like pull out and kind of hold up, and you can see the left brain and the right brain has created these two softwares. But if you're trying to get a sea turtle to fly around your car in an auto commercial, this is the type of software that you use, right? You want to, and a lot of the digital effects software that create these amazing movies are Polygon modelers, and that's a digital clay. So for anybody listening who's struggling with SolidWorks and Pro Engineer or Creo or CATIA or any of these very high-powered CAD systems, if you're looking for something to do faster prototyping in, look to these Polygon modelers and invest the time. A side benefit to the Polygon modeling software is that their output is typically only digital imagery. You can export, and we do it all the time, to make 3D prototypes. And we can export it into the higher fidelity CAD systems, but they are almost universally designed to create digital output, a magazine ad, a commercial, a video output, and so basically you can take your very early concepts, you can make them look like carbon fiber or aluminum or plastic, and painted and shiny and reflective. And so, and industrial design software does all of this stuff, and it's sort of a hybrid between the two softwares. But I've never really worked in that space. But yeah, again, another way to stack the odds in your favor is to deploy more than one CAD solution in your design process, and we do that here at Cirrus.
That's been something that you've done on used for several of the projects that we've worked on that are outside of the Cirrus activities. There's so much that you shared with us today that are valuable nuggets for a career and thinking about projects, even applying to life. Really appreciate the time that you've spent with us here today, Mike.